What if I told you you could build one remote that control almost anything, a robot, a car, even a drone, and switch between ESP-NOW to NRF communication? That's exactly what we are building today, a fully custom 8-channel RC transmitter powered by ESP32. And the best part, the same remote can work as a transmitter and as a receiver. Let me show you how I built it from scratch. I wanted to keep this build simple, so I have used ESP32. It handles the two joysticks, all the switches, displays and the NRF module. To get stable 5 volt, I have used MT36008 IC that step up the voltage to 5 volt, and to charge the battery safely, I have used popular TP4056 charging IC. I have also added a voltage divider so that we can monitor the battery voltage. Now let's move to the PCB layout. I try to make it as compact as possible, and as you can see, the PCB layout looks so good. Now after fabricating the PCBs, it was time to assemble them, but this board has lot of tiny assembly components and applying solder paste by hand is possible, but honestly it's messy and frustrating. So to make it clean and quick, I got this stencil printer from JLCMC, who are also the sponsor of today's video. JLCMC is your one-stop solution for all kind of mechanical parts at really affordable price. They have huge variety of components like linear motion parts, transmission components, aluminum enclosure and accessories, fasteners and lot more. The best part is they provide CAD files so you can drop the parts straight into your own design. They also offer same-day shipping on in-stock items, and ordering is super simple. Just select the part, add it to cart and check out. My stencil arrived within a week, and if you sign up using my link in the description, you will get a $123 coupon. Along with this stencil, I also got a squeegee for applying solder paste, some screwdrivers and set of magnet holders and stoppers. Alright, let's start assembling. First, I place the PCB down and hold it steady using the magnetic support holders. Since my PCB corners are round, I use the magnetic stopper to lock it into place so it doesn't move. Next, I attach the stencil to the stencil clamp. Normally, you would clamp it to on both top and bottom, but I noticed my stencil was a little small, so it didn't quite fit with the upper clamp. No problem, I just use the lower clamp to hold it in position. Now, using the squeegee, I spread the solder paste across the stencil. And as you can see, the paste transfer into the pads perfectly. Now it's time to place the components. First of all, I will place all the assembly components. One by one, I will place everything carefully, starting with the resistors and the capacitors. To solder everything, I'm using my mini hot plate. And I've got to say, watching the components settle into the place as the paste melts, it's very satisfying. Once everything reflows, I adjust few parts to line them up perfectly, and we are done. And as you can see, all the components are soldered beautifully. Now let's add the through-hole parts, the switches, the joystick module and the female header for the display and the NRF module. On the bottom side, I add a female header for the ESP32 along with the power switch and the battery connector. With the soldering finish, it's almost time to install the ESP32, but before that I need to flash the firmware. So I open my Arduino IDE, connect the ESP32 with my laptop, and now just select the board and the port and simply upload the code. And to power the remote, I'm using an 500 mAh lithium-ion battery. Everything is ready. I just add the joystick caps, snap the display and plug in the NRF module, and our remote is ready to go. When it powers on, we greet it with a cool boot animation, and right away the remote is fully working. Both the joystick respond perfectly, all the 6 switches work exactly they should. To actually test it wirelessly, I built a second one just like it. Now here is the best part, I add a feature that let you choose which communication protocol you want to use. By pressing two switches together, you can open the menu and select the ESP-NOW or NRF. Let me show you ESP-NOW first. As you can see, it's working perfectly, the data transmits smoothly with no lag at all, and both remotes run the same firmware, either one acts as a transmitter or receiver. For this test, I'm using an Arduino based receiver, and I switch the remote to NRF mode, and just like before, the data flows across flawlessly. So as you can see, our remote works perfectly with ESP-NOW and NRF. And using any Type-C cable, you can charge this remote and it will full charge within 1 to 2 hours. So you can use this 8-channel transmitter or this remote to control your robots, your DIY projects, and with few tweaks, even drones. For drone controller, the receiver needs some extra optimization, so I will set that from another video. I will leave the cover files, the schematic, and the code in the video description. So if you want to build your own, modify it or improve it, everything is right there for you. That's it for today's video, and if you like this SMT stencil printer, go check out JLCMC using my link in the description to grab $123 coupon. And if you enjoyed this build, hit the like button, subscribe, and I will see you in the next one.